Hello everyone, I am Prateek Kumar. In today's video, we will see the application of Newton's laws of motion with the help of a solved problem. Well, solving any problem involving Newton's laws of motion essentially involves these four steps. The first step is choosing the system and the frame of reference. The system is nothing but any object which we observe as we saw in the video on relative velocity. We were observing a point P of mass m, if you remember that lecture, and then we were analyzing it. So essentially, system is any object or a combination of objects which we observe and on which we do the analysis, right? The next, frame of reference. So this also we have discussed before. What is the frame of reference? So frame of reference is any place from which we make an observation. So depending on the frame of reference, the forces which you consider on the system will change. So as we saw in the last lecture, there are two frames of references, inertial and non-inertial. So first step is choosing the system and the frame of reference. Second step is drawing the coordinate axis. So as I have been laying emphasis in all my lectures, in all my videos, that you should always, before you approach the problem, always lay out the coordinate axis. It will make your life very easier. It will ensure that you don't get stuck in the problem. It's a very systematic way of solving a problem. So second step is laying out the coordinate axis. The third step is drawing the free body diagram. So basically, a free body diagram is a depiction of all the external forces along with the direction acting on the system which we have chosen. So we'll see it in detail in the solved problem. And the last step is writing Newton's laws of motion along the coordinate axis. So once you have drawn the free body diagram, you split the forces along the different axes of the coordinate system you have chosen, and then you apply Newton's laws of motion along the axis, right? So let's start with problem. We have a prism of mass capital M, which is kept on the ground, and the surface of the ground is frictionless. On the slant surface of the prism, there is an object of mass small m which is kept, and this object starts to slide along the surface of the prism, and the surface of the prism is again frictionless. And so as this small m, as this mass of this object of mass small m begins to slide along the surface of the prism starts to accelerate along the left direction. So the problem is to find out the acceleration of this object of mass small m with respect to the prism. Now let's apply these four steps to solve the problem. The first step is choosing the system and the frame of reference. So initially I will choose this object of mass small m as my system, and for it I will choose the prism as the frame of reference. The reason I am doing this is because ultimately I have to find out the acceleration of this small object with respect to the prism. So this small object is my system. The second step is drawing the coordinate axis. Now by the geometry of the problem, I will choose the Cartesian coordinate system, and I will choose the direction of the x-axis parallel to the surface of the prism. So let me denote x-axis along this direction, y-axis will be perpendicular to it. So y-axis will be along this direction. The unit vector along x-axis will be I cap, along y-axis will be j cap. The third step will be drawing the free body diagram. As I mentioned earlier, free body diagram depicts all the forces acting on the system along with the direction. So on this small object, the first force which will act will be its weight, and it will act in the vertically downward direction. The magnitude of the force will be given by mass times the acceleration due to gravity. The second force which will act on the small object will be the normal reaction from the prism. Well, whenever two surfaces are in contact or two objects are in contact, each object by Newton's third law will exert a force on the other object, and the direction of the force will be perpendicular to the surface at which both the objects are in contact. That force is called normal reaction. Why normal? Because it is perpendicular to the surface at which both the objects are in contact. Now since our frame of reference is the prism, and this prism is accelerating in the negative x direction, let's say at an acceleration of a0, so our prism is an non-inertial frame of reference. So on this small object there will be a pseudo force. The direction of the pseudo force will be opposite to the direction of acceleration of the prism. So the direction of the pseudo force will be will be along this direction, Let me denote this direction by this, and the magnitude of the force will be given by mass times the acceleration of the non-inertial frame of reference, which is a naught. Let's fill in all the angles. So this angle is theta, this angle is also theta, and this angle is also theta. The fourth step is writing Newton's equation along the axis, so along the x and along the y axis, right? So let's write Newton's laws of motion along the x axis. So the summation of F vector is equal to ma vector. So what are the forces acting along x direction? The first force which will act is ma naught. I mean, there will be a component of ma naught along x direction, which is ma naught cos theta. There will be a component of mg along x direction, which will be mg sin theta. So if I write the equation, I will get ma naught cos theta. It will be in the positive x direction, so I cap, plus mg sin theta. It will also be in the positive x direction, so again I cap is equal to m. Let's say the acceleration of this object along the surface of the prism is a, so that will be along the positive x direction, so let it be I cap. Along the y direction, what will be the forces? So there will be normal reaction n j cap in the positive y direction, so n j cap. Then the component of ma naught along the y axis, so ma naught sin theta, again in the positive y direction, so ma naught sin theta j cap, minus mg cos theta along the negative y direction, mg cos theta j cap is equal to what? Is equal to 0, because along the y direction this object is not accelerating, it is only moving along the x direction by the geometry of our problem. Now we will analyze the prism and apply these 4 steps on the prism. So first step is choosing the system and the frame of reference. So for the prism, my prism will be my system, and I will choose ground as the frame of reference. Now again, as I mentioned earlier, choosing the frame of reference comes with intuition and with practice. So for that you will have to solve more problems in order to choose the frame of reference, which helps in solving your problem in an easier manner, right? Second, we will be drawing the coordinate axis. So here again I will choose the Cartesian coordinate system, and the x-axis I will choose parallel to the ground and the y-axis perpendicular to it. Third step is drawing the free body diagram. So on the prism, the forces which will act will be again similar to what we discussed earlier. So first force will be the weight of the prism, which will act in vertically downward direction, and the magnitude of the force will be given by mass times the acceleration due to gravity, which is capital Mg. Second force will be the normal reaction due to the object of mass small m. So as we discussed earlier, the prism exerts this this force capital N, which is the normal reaction on the object of mass small m. So by Newton's third law, this object of mass small m will exert back a force of value small n along the along the opposite direction. So this capital N will act with the normal reaction due to the object of mass small m. The third force will be N dash, which will be the normal reaction due to the ground. So as I mentioned, whenever any two surfaces are in contact, there will be normal reaction at the contact surface. So ground will exert a normal reaction N dash perpendicular to the surface, which is along the y direction. So again, so now the fourth step will be Newton's equation along the axis. So along the x-axis, this what forces I'll have? I'll have this this n sin theta. The component of n along x-axis will be n sin theta, and it will be in the negative x direction. So what will I get? I will get minus n sin theta I cap is equal to capital M times acceleration, which is a naught, because the prism is accelerating along the negative x direction, and minus I cap. So this will be the equation along the along the x-axis. Now if you see these three equations, there are three unknowns. So what are the unknowns? N, A naught, and A. And there are three equations, so three unknowns. So I can solve these three equations, and after solving I'll get A is equal to capital M plus small m g sine theta divided by capital M plus small m sine square theta. So this a, the small a, is basically the acceleration of the object of mass small m with respect to the prism, which is what we wanted to find out. So its value will be given by this equation. So thanks for watching this video. In the next video we will discuss about rotational kinematics. Thanks.